Welcome back to the chapter Real Numbers, part 10. So in our previous video, we have been doing some applications related to Euclid's division lemma. So here, the show that the square of any positive integer is of the form 3m or 3m plus 1 for some integer m. Or the question also can be asked in this way. The procedure is the same. So here, we will take let a be any positive integer. So by Euclid's division lemma, we know a is equal to b cube plus r. Here we will take, since it is 3m plus 1, we will take b is equal to 3. So a is equal to 3 cube plus r, where r is equal to 0, 1 and 2. Now so it is the a is of the form, now when r is equal to 0, it becomes 3q plus 1. When it is r equal to 1 is 3q plus 1 and r is equal to 2, 3q plus 2. So we can write, so a is equal to 3q plus 1 or 3q plus 2. Now we have to show that square of any positive integer is of the form this. So now when a is equal to 3q, we have to find a squared. So case 1, when a is equal to 3q, square of it. So a squared is equal to 3q the whole squared. So that equals 9q squared. So you can write this as 3 into 3q squared. So this is equal to 3m, where m is equal to here 3q squared. Now when a is equal to 3q plus 1, a squared is equal to 3q plus 1 the whole squared. So this will become 9q squared plus 2 into 3, 6q plus 1. So we can write this as 3 into, because we have to write it as 3m or 3m plus 1. So 3 into 3q squared plus 2q plus 1. So this is equal to, you can write this as 3m plus 1, where m is equal to 3q squared plus 2q here. Now case 3, when a is equal to 3q plus 2. So a squared is equal to the same procedure only. You have to write and bring it into format of either 3m or 3m plus 1. So 9q squared plus 2 into 2, 4 into 3, 12 q plus 2 into 2, 4. So we can write this as, again we can write this as 3 into 3q squared plus 4q. Okay, yeah, so here I have to write this as, this is equal to 9q squared plus 12q plus 3 plus 1. 4 I am writing as 3 plus 1, so that I can take 3 as a common factor. So this is equal to 3 into 3q squared plus 4q plus 1 plus 1. So this is equal to 3q plus 1, sorry 3m plus 1, where m is equal to here 3q squared plus 4q plus 1. So you were able to write in the format 3m plus 1, here also 3m plus 1. So the square, it is either of the form 3m or 3m plus 1. So if the question is asked as the square of any positive integer is of the form 3m or 3m plus 1 but not of the form 3m plus 2, here you have already proved it is only in this. So you can straight away write it is not of the form 3m plus 2.